mathematical formulation of the transportation problem. Okay, how mathematically how would this problem look like, that we had seen, and we had seen that we can solve, as I said, only a balanced transportation problem in which total supplies is equal to the total demands. So you have to verify this fact first of all, that summation ai is equal to summation bj. Okay, now as I said, the first step would be to look for the initial basic feasible solutions for this. Okay, so that means now we'll be discussing the methods, various methods in which we can find the initial basic feasible solutions for the given balanced transportation problem. Okay, so as I said, there are three methods that we'll be talking of. One is called as the northwest corner rule, the others being least cost and Vogel's approximation. So we'll come to that also later on, but let's start with northwest corner rule. Okay, now as the name itself says, northwest corner, right? See, you have a transportation table that looks like a matrix. इसी तरह से है ना, ठीक है? We have a table. The problem is in the form of a table. So what we do is we start with the northwest corner of this room, of this table. So northwest corner becomes the very first box here. Okay. So what we do is we start allocating from the northwest corner. I mean, what do you want? Do you want me to write the steps or shall I just explain? Huh? Because if I write the steps, then it will take time. What do you want? Jaldi bolo.
Ma'am, steps लिख दीजिए.
Now, the step number 1 would be to, as I said, start with the cell at the upper left, which is actually the northwest. इस table को अगर हम directions में divide करें, so this is your northwest directions. Okay, so we start with the cell at the upper left corner, or which can be called as the northwest corner of the table. Okay, and I mean of the table means the transportation table or the transportation matrix, and allocate as much as possible. Now this needs to be understood. Okay, now this allocation depends upon how much is your total supply and how much is your total demand. Okay, now we have to allocate in this cell. Now this cell corresponds to what? The first source and the first destination. The first source has a supply limited to A1 units, and the first destination has a demand limited to B1 units. Okay, so that means how much do we supply depends upon A1 and B1. So obviously how much can we supply? Obviously the minimum of it. Agar supposing A1 is greater than B1, right? So what we cannot supply A1 because this destination does not require more than B1 units. Okay. Similarly, if B1 is greater than A1, then S1 cannot supply more than A1, right? So when we say allocate as much as possible, this amounts to saying allocation must be equal to the minimum of A1 and B1. Okay. So that means once you have allocated in this corner, then like say supposing if A1 was less than B1, then you have allocated A1 units to it. That means what? That means the supplies from the source 1 get exhausted. It has nothing more to supply because jitna uske paas tha, possibly that what the first source could have supplied, that it has already supplied. So it cannot supply more. So it gets exhausted. But say supposing if B1 was greater than A1, then that means what? The total demand is not met. Okay. How much have you supplied? How much has this first destination received? Out of B1 required, it has received only A1. So how much left? B1 minus A1. So that means this much demand now needs to be met with some other suppliers, right? So what we do is, once this is done, I mean, once we have made the allocations equal to minimum of A1 and B1, then, okay, let's write it properly then. Then in step number 2, what we do is, let's see, if the allocation made in step 1 is equal to A1, as I was saying, okay, then what we do is we move vertically down. Why? Because though the first supply has exhausted, but the first demand has not been met completely. Okay, so we need to fulfill more demands for the first destination. So what we do is we move vertically down into this cell. Now what will happen in this cell? The supplies would come from S2, but demands would be met with what? The first destination. Okay, so we move vertically down. Chalo, I'm now writing the cell number to the cell 2-1. Okay, so it's second row, first column, and repeat step number 1 for the next allocation. That means we'll now allocate the minimum of A2 and B1. Okay, and repeat step 1 for the next allocation. Okay, but this was when the allocation made in step 1 was equal to A1, right? What if this is equal to B1, right? So we say if the allocation made in step 1 is equal to B1, okay? Now, what will happen in that case? I'm just going back to that table. I mean, it was a very small and a rough table, but still to make you understand. See, what happens is that if I make the supply, if I make the allocation equal to B1, that means what? That means the demands of the first destination are fulfilled, but A1 minus B1 amount would be still left with the first supplier. So that means the first supplier has not exhausted its supplies, right? But it cannot give anything more to D1, right? So what we'll do is we'll move horizontally. So we move to the next destination, right? So now the comparison has to be made between A1 minus B1 and B2, whatever we can allocate. Okay, so instead of moving vertically down, we may move horizontally on the right. Okay, so if the allocation made in step 1 is equal to B1, then move horizontally to the cell. Now the cell that we have moved on is 1, 2. Okay, and repeat step 1 for the next allocation. Okay, now this is the second option. The third option could be what if they are equal, right? That means what if A1 is equal to B1? That means we allocate the same number in that cell, right? But then the first supply as well as the first demand is completely exhausted. Okay, so then how to move? We cannot move vertically down. We cannot move horizontally on the right, right? So if A1 is equal to B1, then we allocate X11 equal to A1, which is equal to B1, and move diagonally. Okay, because now not just first source and first destination has been exhausted. I mean, we have to now move to the next source and the next destination. Okay, so we move diagonally to the cell. What will be that cell? 2, 2. So that means now we have to look at the second source and the second destination, because first is, or both of them are exhausted, the source as well as the destination. Then we move diagonally to the cell 2, 2, and we again repeat step number 1 for the next allocation. Is this okay? Now, this is your step number 2. Now, obviously the question is, when will we terminate? Okay, because this has to end somewhere. We cannot just keep on going. Okay, So what we do is we continue this process till an allocation has been made in the, see, we started with northwest. So where should we end? Southeast. Okay, corner of the table. That means right hand bottom corner. Okay, so southeast corner of the table. And this is a very logic based allocation that we are doing. Obviously we are not considering cost at all. We have not even considered what is the unit cost of transportation in each of the cell where allocations are being made. So it's a random allocation that we have done based simply on logic, nothing else. There is no, hardcore, mathematics involved in it, right? We have simply used our logic. Now, say supposing, we may come across degeneracy here. Okay, let me start with just one problem. I don't want to start with degeneracy right now. I don't want to talk of it also, because once this happens, then we have to make a different set of allocations. Okay, let's consider this problem. Say supposing you have a distribution center which is distributing the goods. I'm not going into the details of the history or the the mathematics behind it, the language behind it. For me, I have 3 sources and 4 destinations. Okay, this is the situation. Now we'll start with just one problem, and you will see how each method of finding the initial basic feasible solution is an improvement over the other. Okay, so here I'll write the supplies, and here we'll write the total demands. Okay, now the per unit costs of transportation are 2, 3, 11, 7, then it's 1, 0. There is no cost here. 6 and 1, and then I have 5, 8, 15, and 9. Okay, and the total supplies are 6, 1, 10, and here I have the demands are 7, 5, 3, and 2. Okay, so it's like the 6 is your A1, this is your A2, this is your A3. Similarly, this is your B1, this is your B2, this is your B3, and this is your B4. Now, what is the first thing that we check? Whether summation AI is equal to summation BJ. Now, in this problem, how much is summation AI? 17. And how much is summation BJ? Again, 70. So this is the total supply, and this is the total demand, which are equal. So that means what? That means the given transportation problem is a balanced transportation problem. Is that okay? Now we start the allocations, right? So what we'll do is we start with the northwest corner, right? Now this is your cell number 11, where we have to make the allocations. And the allocations have to be the minimum of A1 and B1. Is that right? Now, how much is the minimum of A1 and B1? It has to be a minimum of 6 and 7. So we allocate 6 here. Okay. Now, that means what? That means the first source will supply 6 units to the first destination. Okay. Now, what in this process, what has happened? The first supply gets exhausted, but you are still left with 1 unit to be given to the first destination because the demand has not been met. Okay. So what we do is we move vertically down to which cell? 2, 1, right? Now in this 2, 1 now again, we have to see, it has to be now the minimum of A2 and B1. Now see, they are equal, right? So what we do, we allocate 1 here. So as a result, what happens? This gets exhausted and this also gets exhausted. So what we do, we have to move diagonal because I cannot move down. I have to move in this direction. Okay. So the moment we move to this direction, that means what? See, now this, isn't it logical? The first and the second source are themselves exhausted now, right? So they cannot allocate anything else. So that means whatever are the remaining demands, they have to be met with the third source only. So we have no other choice but to move to S3D2. Now, when you move to S3D2, it has to be a choice between 10 and 5, right? So what is the minimum of 10 and 5? 5. So we allocate 5 units. As a result, what happens? The second destination gets fulfilled. ठीक है ना? जितना उसको चाहिए था मिल गया. But your third source still can supply 5 more units, right? So where do we move? Horizontally to this cell, right? So how much are we left with? To be minimum of 5 and 3. How much is that? 3. We supply 3 units. This gets exhausted, but you are again left with 2 units. Okay. So where do we go? Horizontally. And in this cell, so what is it? Between 2 and 2, you allocate 2. And as a result, everything is exhausted. Is that okay? So basically, third supply is giving 5 units to second destination, 3 units to third destination, and 4 units to the fourth destination. Is it okay? Now see, the next thing that we have to check, how many allocations have we made? 1, 2, 3, 4, 5, right? So basically, your M was what? 3. Your M was 4. So M plus N minus 1 should have been 6. Remember what I said yesterday, right? We must check how many allocations have we made. In this case, we have made 5 allocations, which is not 6. So that means this is a case of this is a case of degeneracy. Sorry, I was about to write non-degenerate. So this is a degenerate solution. Doesn't matter. In this case, then what we do is, the moment हमारे पास यहाँ पे equal आ गया था ना, A2 equal to B1, right? And since we were moving vertically down, so what we could have done was given a 0 allocation somewhere, either here or here. So it won't make any choice. So even if I allocate 0 here, my allocated cells are now 6 in number. This is how we remove degeneracy. But since it is beyond your scope of this curriculum, so we will not handle. We'll just identify whether my solution is degenerate or non-degenerate. Is that okay? So we'll conclude, we'll write here it's a degenerate solution, doesn't matter. But what will be the cost of transportation? Now see, cost would depend upon how many allocations we have made in each cell. Now we have made 6 allocations in this cell. Per unit cost of transportation was how much? 2. How many units are you transporting? 6. So from this, the cost would be 2 into 6. Then come to the next one. 1 into 1 plus 8 into 5 plus 15 into 3 plus 9 into 2. This will be your total cost of transportation. How much is it? फटाफट calculate तो करो. कितना आया? You can write it in the chat box. No problems. How much is the total cost of transportation here?
116.
116, right? Now say suppose, obviously, I was saying 2 and so on and so forth. As I said, I did not mention the units. It could be 2000 or 200, 300 and so on and so forth. So accordingly, you will have your unit here. So that would be mentioned in the problem. Okay. So you get it as 116. Now see, keep this because I will be handling the same problem with different methods. Okay. Now, as I was saying, this northwest corner is very simple. Even a layman can understand. You don't need a rigorous knowledge of mathematics here. You are moving by logic, right? But definitely, it is the easiest, definitely. But easiest, believe me, cannot be the best. So, obviously, we are not sure whether it's the best initial basic feasible solution or not. Just a minute, girls. So what we do is we move to the next method. Right. Now, the only drawback with the Northwest method is that we have not considered cost of transportation at all while making the allocations. Okay. So that's why the second method that we talk of is called as the least cost method. Okay. So that means this method is going to consider the costs as well while making the allocations, right? So in the least cost method, what we do is your step number one would be to select the cell with the minimum cost. Just a minute, girls. Hanji. So in this case, what we are going to do is now we'll select the cell with the lowest cost in the whole matrix. Okay. That means we look how much is the lowest cost in the whole matrix and start the allocation. Of course, not zero. Okay. In the whole matrix, okay, chalo, let's see. What are we going to do? I took up this problem because this is very interesting. This takes care of all the cases, okay? And allocate as much as possible. See, this allocation depends upon the minimum of, whatever the supply and the demand is. So we select the cell with the lowest cost in the whole matrix and allocate. I'm sorry, this is allocate as much as possible, okay? And which will be what? The minimum of the supplies and the demands corresponding to that cell. Okay. Then step number two would be to eliminate. See, once we do this allocation, either the supply or the demand would be exhausted. That means either the supply would be exhausted or the demand would be fulfilled. Okay. So what we can do is, if the supply gets exhausted, that means that particular source cannot supply to anybody else, right? So what happens is that we eliminate that row or column of the matrix that gets fulfilled, okay? Or that has been exhausted or that gets fulfilled, okay? Now, the if either a row or a column is being exhausted or fulfilled, that's fine. We'll just eliminate that row or column. But what if both are exhausted? Like in the earlier case, when the supply and the demand was equal. Okay. So we say in case both are exhausted, then we eliminate any one of them. Okay. In case both are exhausted, then eliminate any one. Right. And we'll move to step number 3. Fine. Then the other possibility could be, what if there are two cells with minimum cost? See, we are selecting a cell with the lowest cost, right? So I can have just a unique cell with the lowest cost, or I can have more than one cell with the lowest cost. Okay. So in case a cell with lowest cost is not unique, then we can choose, not random, okay, then choose a cell where maximum allocations can be made. Okay, because जितनी ज़्यादा allocations हम एक साथ देंगे उतने जल्दी problem solve होएगा, right? So then we choose a cell where maximum allocations can be made. Okay. Now then step number 3 is we adjust the supplies and demands, that the way we did in the earlier problem. You have to cross and then write the remaining one. So we say after adjusting the supplies and demands of all uncrossed rows and column, of all uncrossed rows and columns, repeat the procedure. Okay. With the, of course, now, once you have crossed the rows and columns, obviously we will not consider those cells. So that means we repeat the procedure with the next lowest unit cost. Okay. So that means we now, in the remaining uncrossed cells, we see what is the next lowest unit cost. Then we repeat the procedures again and again. Okay. So your step number 4 is to repeat the procedure, the whole steps, right? Repeat the procedure till all the sources are exhausted and till all the sources are exhausted and all the demands are fulfilled. Okay, is this clear? Okay, now let's start with the same problem, the one that we started with. जिसके लिए northwest corner use किया था. Okay, I'll just write the problem again. We had how many sources? 3, right? And of course we have to, I hope you are doing simultaneously. वैसे भी मुझे तुम्हारी क्लास में समझ ही नहीं आ रहा कि तुम पढ़ भी रहे हो या नहीं. But it's okay. I'm not bothered. We have the supply and we have the demands. Okay. Now we have to write the table again and again. It's okay. 2, 3, 11, 7, and the supply was 6. Then I have 1, 0, 6, 1. Then 1, and then I have 5, 8. These are the unit costs. 15, 9, and the supply is 10, and it is 7, 5, 3, 2. Okay. Now, we'll consider 0 here. Why? There is a reason behind it. Chalo, dekhte hain. We have already verified that it's a balanced transportation problem with summation ai equal to summation bj equal to 70. Okay. Now, as per the first step, in the whole matrix, we look for the lowest cost. Okay. And the lowest cost happens to be 0, right? So obviously, जहां जब cost ही नहीं लग रहा तो देखते हैं वहां कितना supply कर सकते हैं. So we consider this cell, right? Now it has to be the minimum of 1 and 5. So how much can we allocate? 1, right? So the moment that we do this, this gets exhausted, but you are left with 4 units more to be supplied here, right? So what has happened? One row has been exhausted, right? So what we do is we strike off this row from the table. Okay, that means the other cells of this row are not going to be considered at all, right? Then what is the next step? We look at how much.
Vertical?
No, not vertical. We don't have to go move vertically up or down. We have to
So the
look for
lowest
the
cell.
next lowest cost.
Cell. Okay.
Yes. We have to look for the next lowest cost. Okay. Kahan mein se, out of which cells which are not marked, I mean, which have not been crossed. Okay. So now it has to be a choice between 2, 3, 11, 7, 5, 8, 15, and 9. So how much is the lowest? 2.
2.
Right. So we allocate as much as possible here. And possible kitna hoga? To be a minimum of 6 and 7. So how much do we allocate? 6. So as a result, what happens? This gets exhausted and this is left with still one more to be supplied. But the moment this gets exhausted, this row also gets fulfilled. So it cannot be considered now. Okay. Now we move to the next lowest cost. The moment up next lowest kisme se bacha? Between 5, 8, 15 and 9. How much is the lowest? 5. How much can you supply in this cell? Only 1 unit
1.
because this is zyada chahiye hi nahi. Right? So you're left with 9 here. And the moment you do this, this column gets fulfilled. Okay. Now the next choice. Now it is between 8, 15 and 9. Which is minimum? 8. How much can you supply? 4. How much are you left with? 5. Right? What happened? This column is exhausted. Now a choice between 15 and 9. Which is smaller? 9. How much can you supply? 2. How much are you left with? 3. This column gets exhausted. Only allocation to be made here is 3. Now see. How many allocations have you made? 1, 2, 3, 4, 5, 6. So here your m plus n minus 1 had to be 6. And you have made 6 allocations here. So definitely this solution is non-degenerate because you have made m plus n minus 1 number of allocations. But what would be the cost here? The cost would be 6 into 2 plus 0 into 1 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2. Now, quickly, how much is it? How much is it?
112?
112. Yes. How much was the cost in the earlier case?
116.
6. So this is less than the earlier case. See, when we say, now see, understand this thing. Your problem is, your objective is to minimize the cost of transportation. यही है ना हमारा ऑब्जेक्टिव तो. Of course, we have various constraints attached to it. But obviously, we'll consider that solution better, which is giving me a less cost of transportation compared to my previous solution. So definitely, this least cost method is a better method than the northwest corner method. Okay, because now, see, I mean, obviously, the question can be, what do we mean by better? Or how do we rate a particular method to be better? Ultimately, we have to reach an optimal solution. Okay? If we start with initial basic feasible solution, which is already less, I mean, see, compared to northwest and least cost, say supposing you start your initial solution with the northwest method and then check for optimality. Now, since we've already seen that least cost method is giving me a less cost of transportation compared to northwest, definitely, Northwest method initial feasible solution will lead me to an optimal solution, but in more number of steps compared to least cost, because एक step तो हमको यहीं पे ही cover करना पड़ेगा. But if I start with least cost method as initial, obviously I will reach my optimal solution quickly as compared to Northwest. So that is why we say that least cost is better than Northwest, because it is leading us to our optimal solution in less number of steps compared to the other. Okay, so this is what least cost method is. But then Vogel was another mathematician who said even we can talk of another method which is giving you a better solution and which will lead you to an optimal solution all the more in less number of steps compared even to least cost method. Okay, so that's why the third method that we talk of is called as the Vogel's approximation method. Okay, now what he says is, I mean, the logical difference between the least cost and the Vogel's approximation is that instead of considering the least costs per unit costs, it talks of what we call as the penalties. Okay, now penalties means they are the costs that would have been incurred if allocations in certain cells with minimum unit transportation cost were missed. मतलब अभी हमने क्या करा, हमने इन ऑल सबका लीस्ट कॉस्ट देखा, जहां हम कर सकते थे एलोकेशन किया. हमने कुछ सेल्स मिस भी तो किए. सी जैसे अगर हमने 0 से स्टार्ट करा तो उस रो का 1 हमने मिस किया. ठीक है, जैसे ही हमने कोई और रो को एग्जॉस्ट किया, हमने कोई और सेल उसमें मिस किया. राइट, सो व्हाट इट डज इज कि जो हमने मिस करे मिनिमम कॉस्ट के सेल्स, अगर हम उनमें एलोकेशन करते तो हमारी कॉस्ट में कितना डिफरेंस आता. सो इंस्टेड ऑफ looking at the least costs, we look at the least penalties here. Right, now obviously if you compare, northwest corner was the easiest. Least cost still involved a little bit of mathematics, in the sense that we had to look for the costs, then allocate, and then move on. Right, Vogel's approximation in itself is a little more rigorous than least cost, but it gives you the best possible initial basic feasible solution. So much so that most of the times Vogel's is optimal. That means the solution obtained by Vogel's method is the optimal solution also. You need not improve it. We just check for optimality and then we can conclude that it's an optimal solution. So definitely this method is better. So basically what it does is, instead of minimizing the cost, we minimize the penalty cost. ठीक है, इसका मतलब पेनल्टी कॉस्ट का मतलब क्या, कि जिसको हमने मिस करा उसको ना ऐड करके हम क्या लूज कर रहे हैं, हम उस चीज को मिनिमाइज करते हैं in case of Vogel's approximation method. Okay, so that way this serves as the best. Okay, now as I said, this needs more calculations, more steps involved in it, but still it's the best, right? So you have to understand this method more. This you have to understand this method थोड़ा सा ज्यादा अच्छे से. Okay. Now, as a step number 1, what we do is we calculate the penalties for each row and column. Okay. Now, penalty का मतलब क्या हुआ? That is nothing but we take the difference between the smallest and the next smallest unit transportation cost. अब यहां से समझ आएगा कि पेनल्टी का मतलब क्या है. Next unit transportation cost in the same row or column. ठीक है, देखो इसका मतलब क्या हुआ. Least cost में what did we do? We just looked for the minimum cost in the whole matrix and then started the allocation. But now what we are doing is we are analyzing each supplier and each destination separately. What are we doing? We are for each row, we are looking at the smallest and the next smallest cost. ठीक है, तो अगर हमने स्मॉलेस्ट में एलोकेशन किया तो नेक्स्ट वाले को हमने कहीं ना कहीं उसको छोड़ दिया, लूज कर दिया, राइट. अब इन दोनों की कॉस्ट का जो डिफरेंस है, अगर हमने नेक्स्ट वाले को एलोकेट नहीं करा तो हो सकता है हमने कुछ लूज किया हो, कुछ पेनल्टी देनी पड़ी हो हमने अगर उसको एलोकेट नहीं करा. सो व्हाट वी डू इज फॉर ईच सप्लायर and for each destination we calculate the penalties. Okay, that means for each row we look at the smallest and the next smallest and take the difference, right? So what will happen for each row and for each column, penalties would be computed. This is the first step, right? Then what we do is, अब penalty क्या है? Penalty is the loss that I could have incurred अगर मैंने उसको कंसिडर नहीं करती. ठीक है, तो डेफिनेटली हम सबसे पहले किसको हटाएंगे? जहां से मेरे को सबसे ज्यादा पेनल्टी पड़ रही है, ठीक है ना, जहां से मेरे को सबसे ज्यादा नुकसान होने का चांसेस है, राइट. सो व्हाट वी डू इज इन स्टेप नंबर 2 we select that row or column, select that row or column with the largest penalty. ठीक है, जहां पे हमारे को पेनल्टी सबसे ज्यादा आ रही है, राइट. नाउ अब ये क्या है कि this will make use of the least cost method also, in the sense that we select that row or column with the largest penalty and allocate as much as possible in the cell that has the least cost. Okay, as much as possible in the cell having the least cost in that selected row or column. अब ये किसी से भी आ सकती है. इसका मतलब हम डेस्टिनेशन या सोर्स से नहीं शुरू कर रहे, कहीं पे भी कुछ भी फुलफिल हो सकता है, राइट. Having the least cost in that selected row or column. You know, the maximum penalty could have come due to the source, or the maximum penalty could have come due to the destination. Okay, so we choose that maximum penalty and allocate as much as possible in the cell having the least cost, right? Now once, of course, allocate as much as possible का मतलब तो वही है, minimum, right? Now we adjust, जैसे अभी तक करते आ रहे थे. Step number 3, we adjust the supply and demand. ठीक है, कौन fulfill हुआ, किसके पास कितना बचा, we adjust that. We make those adjustments. We apply the supply and demand and cross out the satisfied row or column. ठीक है, जो भी फुलफिल हो गया, चाहे सप्लाई एग्जॉस्ट हुई, चाहे डिमांड फुलफिल हुआ. So anything that is satisfied, we cross out that row or column. Okay, so any row or column with zero supply or demand should not be considered in computing for the future penalties, right? So basically the purpose is कि जब हमारे पास कोई भी रो या कॉलम सेटिस्फाई हो गई, right? So we will not consider that at all. So उस रो में या उस कॉलम में जो भी costs हैं, we are not going to consider them. But as a next repetition, we have to again compute the penalties. We have to again look for the maximum penalty. We have to make the allocations and so on and so forth. Okay, so that's why this is your step number 4, which says that we repeat steps 1 and 2 till all the supplies have been exhausted and all the demands have been fulfilled. Okay, till all the supplies have been exhausted and all the demands have been fulfilled. Okay, now let's do with this the same problem. Now make a table. Now I need more space on the right as well as down because we don't know how many times we have to compute the penalties. So I'm starting from here now. Okay, so we had 3 sources, S1, S2, S3, and we had 4 destinations, D1, D2, D3, D4. Okay, we had the supplies here and we had the demand here. Okay, right. Okay, I'm sorry, I have to write the cost again. Do it along with me. I think it will be better. But again, the choice is yours. 2, 3, 11, 7, and this was 6. Then 1, 0, 6, 1, 1. Then 5, 8, 15, 9, 10, and then we have 7532, right? 2, and summation AI was equal to summation BJ, which is 70. Okay. Now, what we are going to do here is compute the penalties for rows and compute the penalties for columns this way. Okay. Now, how do we compute the penalties? As I said, the difference between the least cost and the next least cost. Okay. Now, the least cost here is how much? 2. And what is the next least cost? 3. The penalty is how much? 1, right? The least cost here is 0 and the next least cost is 1. So 1 minus 0 is 1, right? The least cost here is 5 and the next is 8. So it becomes 3. These are the penalties for the rows, first set of penalties rather. Okay. What about the columns? It's going to be 2 minus 1, 1. Then 3 minus 0, 3. Then 11 minus 6, 5. And 7 minus 1, 6. Is that okay? Right?
Yes, ma'am.
Now, in the penalties, which is maximum? 6. ठीक है ना? So what we'll do is, and 6 belongs, the maximum penalty belongs to what? The fourth column or the fourth destination? Okay, that's what the step said. We have to choose the row or the column that has the maximum penalty. In this case, it's the column. Fine, it's okay. Now, in this column, we will look for the minimum cost. What is the minimum cost here? 1, right? So that means we are going to make allocations in this cell. The point is, how much can we allocate? Now, that depends upon 1 and 2. So it has to be the minimum of 1 and 2. So how much can we make? 1. We allocate. What happens? This gets exhausted, but this gets left with 1 more unit to be supplied to. Now, the moment this gets exhausted, what happens? This source gets exhausted. Okay? So that means this row has to be striked off, as it will not be considered in the evaluation of further penalties. Are you getting the point now? Okay. Then we compute the next set of penalties here. Now see, it may happen that for certain rows or columns, the penalties will not change in the next set because that has been not, maybe the minimum or the next minimum has not been striked off. Doesn't matter. Okay. Like in the first row, your minimum is still 2 and the next minimum is still 3. So the penalty is still 1, right? But since the second row has already been striked off, so we will not compute the penalty here, right? Similarly, in the third row, the penalty still happens to be 3. Is that okay? What about the first column now? Now see, in the first column, the minimum is 2. And the minimum is not 1 now because that has been striked off, right? So what is the minimum? 2. Next minimum, 5. So how much is the difference? 3. So the penalty changes here, right? Similarly here, that's what I said. The row or the column that has been striked off, the remaining cells will not be considered for the evaluation of further penalties. Okay. Similarly here, the smallest is now 3, the next smallest is 8, so the minimum is 5. Similarly here, 11 and 15, so it's 4. Then 9 and 7, 2. Is that okay? Now, what is the maximum penalty? 5. Belongs to where? The second column, right? So we look at the second column. What is the minimum cost? 3. So we make an allocation here, right? Allocation to be the minimum of 6 and 5, right? How much can you allocate then? 5. So this gets exhausted and you are left with 1 here. Is that okay? Now, the moment this gets exhausted, that means the second column gets striked off. Is this okay? Now we move on to the next set of penalties. So as I said, we don't know how many set of penalties we have to compute, but still, this is not much of a big deal here. So now again, we compute the third set of penalties here. Now see, since this column has been striked off, your minimum is still 2, but the next minimum is 7. So the penalty turns out to be 5 in this case. So it will change now. Second row, we don't have to consider. Third row, the minimum is 5 and the next minimum is now 9. So the penalty becomes 4. Is that okay? Now for the first column, yes, it does not change, fine. And since the second column has been exhausted, so we do not compute. The third column remains the same and this also remains the same. Okay. Now, the maximum is again 5, right? Now we see how much can we allocate. 5, we look at the first row. The cell with the minimum cost, the first cell. How much can we allocate? The minimum of 1 and 7. So we allocate 1. You are left with 6. This gets exhausted and the first row gets exhausted. Move to the next set of penalties. This is not to be considered. This is not to be considered. The penalty is still 4. In the first column now, the penalty is 5 because there is nothing else left. This is not to be considered. This is 15 and this is 9. Okay. So now, what is the maximum penalty? 50. We go. No other cell where allocation can be made except this. Okay. Now, this has to be the minimum of 3 and 10. So we allocate 3 here. This gets exhausted. You are left with 7. And this column gets exhausted. Is that okay? Now, this is not to be considered. This is not to be considered. What is the penalty? 4, right? Now, for the columns, this penalty is 5, not to be considered, exhausted. This penalty is still 9. So how much is the maximum? 9. So we allocate in this cell. How much can you allocate? Only 1. This gets exhausted. You are left with 6. Now see, you will be left with only one cell where allocations can be made. Right? And you will see that you have no choice. But this gets 6. Okay? So this becomes your allocation. Now, what has happened? The moment you allocate 6 here, even this gets exhausted, and your problem is over. I mean, problem of finding the initial basic feasible solution. Okay. Now see, how many allocations have we made? 1, 2, 3, 4, 5, 6. Is that right? So again, your m plus n minus 1 was 6. So your solution is non-degenerate, perfect for us. Okay. But what is the cost? Your cost is now 2 into 1 plus 3 into 5 plus 1 into 1 plus 5 into 6 plus 15 into 3 plus 9 into 1. हाँ जी, कितना आ रहा है?
मैम 102
102. ठीक है ना? तो अब ये तो लीस्ट कॉस्ट से भी कम हो गया. Can you see the logic? जरूरी नहीं जहाँ जीरो कॉस्ट ऑफ ट्रांसपोर्टेशन हो वो हमें मिनिमम टोटल कॉस्ट ऑफ ट्रांसपोर्टेशन देगा. In this, we have not allocated any, and we have not made any allocation to a cell where the cost of per unit cost of transportation was 0. So that's not always helpful. Okay. So, and still we have got a cost of transportation which is less than least cost. So definitely this method is better than the least cost even. Okay. So like now from examination point of view, if the problem comes, solve the given transportation problem. That means you have to find the initial basic feasible solution. You have to test for optimality. And if improvement is required, you have to improve. Okay. So in that case, my suggestion is start with Vogel's approximation. Find the initial basic feasible solution using Vogel's approximation, because this will always lead you to your optimal solution in less number of steps as compared to least cost and northwest. Is this clear?
Yes, ma'am.
Yes, ma'am.
All the 3 methods?
Yes, ma'am.